Happy Friday, guys, and happy last day of notes. This is the last section that we need to cover for the year, so congratulations, you're almost done pre-calc. Hopefully you printed out the fill in the blank notes to make things easier, but today we are doing our last section, or part of section 12.2. We're going to focus on rationalizing and infinities. So here's an example. I want us to use direct substitution. So anytime I say use direct substitution, hey, guess what? You have to use direct substitution. Even if you're so smart, you can predict what's going to happen. That's amazing. But I want you to show your work. And hopefully you're like, oh snap, I now know exactly what's going to happen. And if you don't, well, it's okay. We all have pandemic brain. So 3 minus 3 is 0, and 9 minus 9 is also 0. So this is and this is where you guys would stay silent and stare at me in class. Miss those days. This is the indeterminate form. So normally, right, yesterday at least, based off yesterday, I taught you guys to factor if you get to the indeterminate form, because this might actually have a limit that exists, but you can't factor this. So another technique to find limits that have indeterminate form I can't believe it's the end of the year, guys, is to rationalize the numerator or denominator. And divide out any common factors. So it's a little bit different than what you're used to. You're used to rationalizing the denominator because we don't like radicals in the denominator or complex numbers in the denominator, but you can actually use rationalizing in numerators. And this is a specific case where you would want to do that. And so let's do it algebraically so you can see why. I'm going to rewrite this. Okay. So if we're going to rationalize, I don't know why I did that. We want to multiply by the square root of x, almost wrote 3, and then it's plus 3. Remember, so square root of x plus 3, so we're changing the sign. And remember, the idea of rationalizing is so that we get rid of that radical in the numerator. So the square root of x times the square root of x will be square root of x squared, which is just x. And then if you don't remember part of the reason we rationalize too, right, we have plus 3 root x and then minus 3 root x, and so those end up canceling, and then we have minus 9. Then in the denominator, x times the square root of x. Actually, what you want to do is leave this factored, and I'll show you why in just a hot sec. So I showed a little bit more work in the numerator. I'm just going to erase it because I know that this is just going to be x minus 9. And that is why I didn't want you to try to actually FOIL that out. X minus 9 and x minus 9 cancel out. So we're left with just 1 over the square root of x plus 3 for our limit. And now we can use direct substitution. So that's going to be 1 over the square root of 9 plus 3, aka 3 plus 3, so this is 1/6. So the limit as x approaches 9 of that function is 1/6. And we're done. So pause the video and attempt these two examples now. And yes, you need to use direct substitution first, even if you know what's going to happen, because I don't know, it just follows our notes. So pause the video and then hit play when you're ready to go over it. Okay, hopefully you're done. So looking at example A, yes, as I've said multiple times, and hopefully you're not just skipping through this video so you see this and don't mess it up on your quiz and test, you need to show that line. I need to see that you get the indeterminate form, because once you have the indeterminate form, that's when you can decide, okay, now I'm going to rationalize and go from there. So the limit as x approaches 4, I'm rationalizing the numerator here, and then canceling my common factors. I substituted everything in, or just the 4 in, I don't know why I said everything, and you get 1/4. For B, same idea, show this line first, get the indeterminate form. I can't factor, so I rationalize, and you should get 10, and here you're rationalizing the denominator. So now let's move on to infinities. So limits of power functions with infinity is what we're going to talk about next, super fast. For any positive integer n. So before we talk about this part right here, I want us to remember when you have a polynomial, right, going up, up. So if this is f of x in this case equals x to some n power. And if the graph is going up, up, remember that means n is even. And then if it is down, up, right, so going in opposite directions, f of x here equals x to the nth power. This happens when n is odd. So there are two essentially different ways the graph looks. It's either going in the same direction if it's even, or opposite directions if it's odd. So for any positive integer n, if we have the limit as x is going to positive infinity, oops, I messed these up. Okay, well, we'll fix it now. So the limit as x is going to positive infinity of x to the nth power. If it's going to positive infinity and it's x to the n, this is going to equal infinity, always. If it's going to, and this is where I messed up, these two should be negative infinity, so if you could change them, I wish there was a way, can I color in white? Is that possible? Okay, I guess I'll pause the video and try to figure it out. It worked, guys. Okay, where was I? Purple. So if x is approaching negative infinity, it's gonna approach positive infinity if n is even, and as x is approaching negative infinity, it's gonna approach negative infinity if n is odd. So basically, you can kind of just look at your polynomial function and look at the degree, and is it even or is it odd? And then from there, are you going to negative infinity or positive infinity? So let's go through it. The limit as x approaches infinity of 2x cubed minus 3x to the 5th plus 4x to the 6th. So first of all, what is our leading term? I'll use a different color. Let's use teal. I don't know if I used this yet. I don't remember. Okay. So this is going to be our main focus. So we can just think of it as the limit as x is approaching positive infinity of 4x to the 6th. Now, we can apply our properties. So that's going to be 4 times the limit as x approaches infinity of x to the 6th. And now it is going to positive infinity, and it is an even exponent. So that is going to be 4 times infinity, right? Positive infinity, even exponent, going up towards infinity for the end behavior. And then 4 times infinity is just going to be infinity. So the limit for this whole thing equals infinity. So pause the video. I really want you to try to do this on your own and see if you can figure it out, and then hit play and I'll go over it. So for this, I'm actually going to show the steps. So we look at the highest degree. In this case, it's x to the 6. So I can rewrite this just focusing on x to the 6. And be careful here because this is negative infinity. So if it's going to negative infinity and this is even, it's actually quite simple. It's going to be positive infinity. Now pretend this was odd. Pretend it was a 7, then it's negative. So now let's look over here. Okay, so negative 3x to the 4th is what we want to focus on. That's our leading term. So the limit as x is going to positive infinity of negative 3x to the 4th. So we need to separate the exponent and the coefficient. So we use our properties of limits. So negative 3 times the limit as x approaches positive infinity of x to the 4th. So just focusing on the parentheses, because it's going to positive infinity and this is even, that means that that whole limit is approaching positive infinity. Now here's the thing. This is a negative 3. So negative times infinity is going to make this whole thing go to negative infinity. So our conclusion up here is the limit as x approaches infinity of that polynomial, we are going to negative infinity. And that's it. So let me know if you have any questions, but we're going to have a flex time probably on Monday since you have a quiz on Tuesday. And don't forget to do your homework. Congratulations, guys. You are done with taking notes in pre-calc.